Lesson 3-5, Arithmetic Sequence. A sequence is a set of numbers called terms in a specific order. So the terms are the actual numbers, and they have to be in a specific order. An arithmetic sequence is a numerical pattern that increases or decreases at a constant rate. That constant rate is called a common difference because something has changed. So in the example below, we have 3, 5, 7, 9, and 11. The arithmetic sequence there is plus 2 because you're adding 2 to every one. So we would be able to say that this is an arithmetic sequence and its constant rate is plus 2. So we need to learn how to identify arithmetic sequences. So you have 4 numbers here, -4, -2, 0, and 2. We want to identify if it is an arithmetic sequence or not. If it's not, then we need to explain why. If it is, then we want to identify how. So in this example, we have -4 to -2. So to do that, you add 2. From -2 to 0, you add 2. And to 0 to 2, you add 2. So we would say yes, and we would say that this is an increase of 2. Now if we had the example of -26, -22, -16, and -12, we would see that -26 to -22 is plus 4. -22 to -16 is plus 6, and then -16 to -12 is plus 4 again. So even though we have 2 that repeats, this would not be a sequence because the pattern does not repeat. There's no common difference. So there's no common difference for this example. Make sure that when you're trying to determine if it's an arithmetic sequence or not, that you're using all the terms and you're trying to figure out the relationship between each term. Because just because something repeats for the first 2 numbers does not mean that it's going to continue to repeat all the way through the pattern. Pause the video to try a few examples. The first example is 1, 4, 9, and 15. The relationship to 1 to 4 is plus 3, 4 to 9 is plus 5, and 9 to 15 would be plus 6. So for this example, you would say that this is not an arithmetic sequence because it does not have a common difference. The number is not consistent, so this would be no. And for the next one, you have 1/2, 5/8, 3/4, 13/16. The relationship from 1/2 to 5/8 is plus 1/8. The relationship from 5/8 to 3/4 is plus 1/8. The relationship to 3/4 to 13/16 is plus 1/16. So you can see that even though the first 2 are the same, the third one was different, so we would say no. So when we're using arithmetic sequence, we can also use this to find the next term. And you guys probably did this when you were in younger grades where you were just finding the pattern and then it said find the next term. So to do that, you want to find the common difference between the terms. So 15 to 9 is you subtract 6. 9 to 3 is you subtract 6. 3 to -3 you subtract 6. So that means that your relationship is that you're subtracting 6 each time. So then you take your last term, you perform whatever's happening. If it's plus 2 or subtracting 6 or whatever the relationship is, you do that to the last term. And then you get your next term, in this case, which would be -9. Now sometimes they'll ask you for the next 3 terms. So you would continue the pattern until you got all 3 terms of -9, -15, and negative 21. Pause the video to find the next three terms. So in this example, you want to find the pattern between the numbers. So from 12 to 8, you are subtracting 4. 8 to 4, you're subtracting 4. 4 to 0, you're subtracting 4. So that means your pattern is to subtract 4. Now you continue this to find the next three terms. So 0 minus 4 is negative 4. Negative 4 minus 4 is going to be negative 8. Minus 4 would be negative 12. So we can also use arithmetic sequence to find the nth term. So sometimes it will ask you to actually find the nth term, which means it wants the equation to find it, or it will give you a number. So it may say to find the 15th term, or to find the 11th term. So there's a formula for that, and that formula is AN equals A1 plus N minus 1 times D. And the A1 is the first number in the sequence. So A1 is the first number in the sequence, and the D is the actual relationship, or what they all have in common, or the pattern. And then the rest, you can just kind of solve from there. So let's look at this example. We have negative 12, negative 8, negative 4, and 0. So the pattern between each of those is we are adding 4 to each one. So if we follow our formula, AN equals A1, which is my first term, so negative 12, plus N minus 1 times the pattern, which is plus 4. So now from here, you kind of start to solve through, and you get negative 12. Make sure you distribute the 4 into everything, so you get plus 4n minus 4. Now you can combine your like terms, and so you get 4n minus 16. So this would be an example of the equation for finding the nth term. Now, if you wanted to take that one step further, and if the question asked you to find the 9th term, you could use that equation and you can find the 9th term because you plug in the number of the term that they want, so in this case 9, for n. So 4 times the 9 minus the 16. 4 times 9 is your 36, minus 16 is 20. So the 9th term, if you were to continue out the pattern, would be 20. You may also be asked to graph the first so many terms of a sequence. So in this example, it's asking you to graph the first 5 terms. So that means that you're going to replace that n with the number of the term. So the first term, the second term, the third term, the fourth term, and the 5th term. So when you solve all those out, you would have negative 12, negative 8, negative 4, 0, and 4. And then you could just very easily put those on a graph with your x being the place of the term, so 1, 2, 3, and 4, and your y actually being the number that you found. So for the first term, we could graph it at 1, 112, the next one you could graph at 2, 8, and so on. You can also use that equation that we had set up, the 4n minus 16, to figure out which term of the sequence is a specific number. So by doing that, when we first wrote out the equation, we had a1 equals, or an, equals something. Well, that an is the term that you're looking for. So we would plug this 32 in for an, because that's the number, minus 4n minus 16. So you add 16 to both sides. So you get 48 equals 4n. Then you divide both sides by 4. And so you would determine that the 12th term in the sequence would be 32. Pause the video to complete the lesson review. Make sure you show me this lesson review for verification of this video.